Ruby. First, Ruby has a high level syntax, which means that the code is very easy to read and write. So you don't have to deal with a lot of low level details like in C or C++. Second, Ruby is dynamically typed. That means that you don't have to explicitly declare a variable types. You just assign a value and Ruby will figure it out for you. So no need of int character declaration and all. It automatically identify what sort of variable we were declaring it. So this makes development faster and more flexible too. And third one will be Ruby will provide automatic memory management through garbage collection. So in languages like C, we need to manually allocate and free up the memory. And mistakes can be easily lead to crashes also. But Ruby takes care of this for us. So the developers can focus on solving the problem rather than worrying about memory leaks. So finally, Ruby is fully object-oriented language. In fact, everything in Ruby is an object. Already I said even numbers, string, functions, everything in terms of called by object type. So this makes the code more modular and reusable and consistent too. Now, now how is Ruby actually used in real world application? Actually, Ruby is very popular in web-based development, especially through Ruby on Rails framework, which powers the larger platforms like GitHub and Shopify. So it is also widely used for scripting and automations. Things like writing small utilities or automating the repeated task and testing test the automation process like that. So actually Ruby is great for general purpose programming, but traditional Ruby is too heavy for embedded system with limited memory and CPU. And more recently, Ruby was entered into simplicity to embedded devices, which allowing us to write high level script uh, high level script with very number of less code. Ruby will be renamed as mRuby, that means microcontroller Ruby for microcontrollers. It brings Ruby simplicity to embedded devices. So it trimmed down to make it suitable for all sort of embedded constrained devices. Now we can to start working with Ruby, first we need to download and install it from the provided link. So this will be, I'll give that link, I'll post this particular link in the chat box later. So you just go download this available Ruby, which is available in the website and available Windows based on your operating system like Windows, Mac OS or Linux. For beginners, it is easiest way to use will be very much simpler only. Like whenever we will be trying to install some other way to use similar way, this can be very much simpler one. For Windows, like, for example, I am trying to you can download the latest Ruby some other way to use similar way, this can be very much simpler. For Windows, for example, I am trying to can download the latest Ruby with some other way to use Ruby, can be very much simpler. For Windows, for example, I am trying to can see on any sort of that Ruby with some other way to use Ruby, can be very much simpler. For example, Ruby on Ruby or any sort of that Ruby with some other way to use Ruby, can be very much simpler. For example, always Ruby on Ruby or any sort of that Ruby with some other way to use Ruby, can be very much simpler. For example, always Ruby on Ruby or any sort of that Ruby provided on Ruby, can be very much simpler. And these are all the basic syntax provided on Ruby. We have Ruby automatically handle the type of data for us. Similarly, loops and conditional will work in a such a way in C logic way through syntax syntax will be more readable. So the knowledge we gained in C will be strong foundation. Now in Ruby, we are simply learning how to express those same ideas in different styles. Now, when it comes to mruby, it follows the same Ruby syntax and concept, but it is specifically designed for embedded system. This means when it comes to mruby, it follows the same syntax and concept, but it is specifically intended for embedded system. This means the way we write the code for variable, loop, or method, or any sort of classes will be almost the same which is followed in C or Ruby. The only difference is that mruby is lighter and faster and suitable for devices with memory constraint. That means limited resources. So the strong foundation we built it in C will help us to understand the logic, and transition to Ruby and mruby is mainly about learning the simpler syntax and applying it in the different environment. Now, without any further delay, we will already we understood some basics of Ruby. Let's move on to mruby, which is essentially Ruby designed for embedded system. First, mruby is lightweight implementation of Ruby language, while regular Ruby is powerful and it is too heavy for microcontroller or small IoT devices. But mruby solves this problem by bringing Ruby's simplicity and readability to the devices that have very limited memory and CPU resources. Second, same about the author. Just like Ruby, mruby is also created by Max, which who is who under the open source. Excuse me. mruby is MIT licensed and open source software, which means a developer can freely use it, modify it, and even they can include it in a commercial product too. So third one will be one of the most and keys, and even mruby can include it can be embedded directly into C or third one will be one of the most and this is much more important because can be embedded directly into C or third one will be one of the most and this is much more important because can be embedded directly into C or third one will be one of the most complex and much more important because can be embedded directly into C or third one because and then we can write it because high level language because and then we can write it because imagine you are high level language because and then we can write it because imagine you are high level language because and then we can write it things can be written in C, but the automation logic such as if the motion is detected after 7 p.m. Imagine mruby can the automation logic. So this makes the development is detected after 7 p.m. mruby combines both power and control of C with simplicity and flexibility of Ruby in a form that is efficient enough for embedded system. Next, we will move on to benefits of mruby in embedded platform. So, what benefit does mruby bring to embedded developers? First, will it allows high-level scripting on low-level resources devices. This means you don't have to write everything in low level. Instead, you can use Ruby for simpler, cleaner, and more readable code. Second one, it support rapid prototyping. That means you can quickly test new logic just by changing the Ruby script without recompiling the entire firmware. So this saves lot of time during the development. And third one will be it makes updates much easier since the logic can live inside the Ruby script. So you can push updates or change the updates without touching the core C code. So fourth one will be mruby encourages the modular and reusable code because Ruby is object oriented, so you can organize your code even better and reuse the component more effectively. So in short, we can say it mruby reduces development time and increases flexibility and lower the maintenance cost, which are major advantages of for embedded developers. Now we will be so yeah, mruby is not just a theoretical concept. It's already being used in real world application which providing the practical values. So let us discuss some of the examples. So first we'll discuss about IoT devices. In internet of world, every devices like sensors, smart sensors or connected appliances, gateways are always often have very limited memory and processing power. So traditionally, developers need to write everything in C or C++, which can be time consuming. So with the mruby, you can embed a small Ruby interpreted and run lightweight script to handle the data collection and communication and make the process to be automated. So this makes IoT solution faster to develop and easier to update. And second application will be in automotive systems. So all modern vehicles like EV vehicles have dozens of microcontroller controlling everything from the in-front maintenance system to diagnostic tools. So companies are exploring the mruby to script features inside the cars, such as customizing the display interface or adding diagnostic logic or without rewriting the entire firmware. Because mruby is small and embeddable, so it fits perfectly into the automotive electronics. And third application will be mruby is small and embeddable. In robotics, so it the developers perfectly into the automotive robots behavior. And third application will be different movements or responsible robotics, so it a little bit perfectly difficult. So everything is third application different movements or responsible robotics, so it little bit perfectly difficult. So everything is third application different movements or responsible high level that way difficult. So everything is third application engineering or high level that way everything is third application engineering or high level that way everything is third application engineering or high level and flexibility. So mruby allows manufacturers to add customizable features and automate update and let the user to extend its functionality with the script, all without bloating the entire system. In telecommunication equipments, particularly in routers, switches, and network devices, there is a need for custom logic. And also monitoring and configuration scripting. mruby provides a safe and lightweight way to embed scripting directly into a networking hardware and allowing operators to automate the policies and test the features more quickly without flashing new firmware. In industrial automation, particularly in factories, embedded controllers manages machines, sensor, and production lines. Instead of writing low-level code, mruby can be used to script workflows that can handle the machine to machine communication, and or even it can adjust the process in real time. So this makes industrial system to be more adaptable and easier to maintain. So as you can see, mruby is not just an academic exercise. It is enabling scripting and scripting language, and providing the flexibility in real world embedded application system. Let us discuss about difference between ruby and mruby. So now we have understood that what mruby is. It is now it is important to see the difference from the standard ruby implementation that most of us are familiar with it. So let's walk through a side by side comparisons. First, let's look at the size. The standard ruby interpreter is quite large. It's about 20 MB when compiled. That's perfectly fine if you are running Ruby on a PC or servers, or even for web-based applications. But for microcontrollers or a small IoT-based devices, 20 MB is 20 MB is too heavy. In contrast, mruby has much smaller footprint. It usually sits between 100 to 500 kilobytes, depending on which features you can enable. So this is tiny when compared to Ruby. So, and it is small enough to run on embedded system, IoT devices, and even a wearable gadgets also. So here the much important key takeaway is that mruby is lightweight and optimized for limited environment. That means resource limited environment. The next use case will be ruby is general purpose language. It is very popular for in web development, especially with ruby on rails framework. It is built for environment where resources like CPU power and memory are abundant. But M2B, on the other hand, was designed specifically for embedded system. Its main goal is to bring Ruby simplicity and readability into one small devices with tight resource limits. So you can remember like this. So Ruby is for PC and web, and mruby is for embedded devices. Now let's look at the libraries. A standard ruby ships with the huge standard libraries. So it has everything you can imagine: networking, file handling, database, advanced data structures, and you can have a number of it. But mruby takes a very different approach. To remain lightweight, it comes with only one a limited set of libraries. So the developer can decide which modules to be included when they compile it. So, and if you need any extra functionality, you can even write customized modules in C and integrate with them. So the key point here is that ruby has everything out of box, while mruby is modular and customizable. So moving on to the execution, Ruby runs on full virtual machine called yet another Ruby virtual machine. YARV. That means yet another Ruby virtual machine. So this provides the complete Ruby language experiences, but it is require more resources. And on the other hand, mruby runs on the lightweight virtual machine. It executes Ruby scripts in bytecode form. It does not have any single Ruby feature, but it still supports essential syntax and functionality needed for scripting in embedded system. So here the key takeaway is that Ruby will prioritize completeness, whereas mruby will prioritize efficiency. So another big difference is embedding. So standard mruby was never designed to be embedded inside another application. It is simply too big and does not integrate well with the C-based systems. But mruby was built this exact purpose. So it explicitly designed for embedding in C or C++ application. So you can integrate it directly into the firmware and call C function from the Ruby and write the Ruby scripts seamlessly on the device. So here the message is very clear. So mruby will be built to live inside embedded system. Ruby is not. So let's talk about the performance. Ruby is optimized for desktop and server environments. It consumes you have enough memory and CPU cycles to handle the interpreter, libraries, or runtime. So running 20 MB interpreter with multiple library is no issues on those machines. But on the other hand, mruby is tuned for environment with a very tight resource constraint. So think about a microcontroller that has only a few hundred kilobytes of flash memory. In such conditions, mruby is designed to be fast, efficient, and predictable. So it's especially well suited for real time systems where response times is really matter. So the performance wise, each one shines its own environment. And finally, flexibility. Ruby's flexibility comes from its massive ecosystem. So it have gems which are reusable and packages, plus frameworks and libraries for most every sort of domain you can think of it. So web development, machine learning, automation, and many more. Developers can quickly build rich and complex set of application to this ecosystem. But mruby's flexibility works in a different way. It is modular by design, so you can only include features you need when you compile it. So if you want networking, you can add it. If you don't want to if you don't want it, you can leave it out to save the memory. So, and to make even more powerful, mruby includes an foreign function interface, FFI. Normally we will be calling it as an FFI, that allow ruby scripts to directly call c functions. So this gives a best of both the worlds. That means high level scripting combined with low level control. So ruby is flexible because of its huge ecosystem, but mruby will be much more flexible because of its modularity and embeddability. Next, we will move on to mruby architecture. Let's walk through these architecture step by step, from starting from the left side of the diagram. So development side, which we will on the left side, we have a developer laptop. So this is where all the code is run, that means written either in ruby or c or anything c++ also. Now you must may wonder, how does this code get ready for esp32 board? That's where ES press if toolchain, which will be available on the top of the desktop computer, comes in. It provides the compiler, linker, and debugger needed to be built applications for ESP32 chips. On the top of that, we use ESP IDF, the official IoT development framework for ESP32 device. So it gives us drivers, APIs, and networking libraries. Finally, there is something special called family ruby. This is the layer that brings mruby into esp32. It includes mruby compiler and runtime, so the ruby scripts can actually run on the microcontroller. So together the process will be much simple. So developer write the ruby scripts and compile them in espidf, and then flash the firmware into the board using serial communication. So once the code is ready, it is uploaded to the NARIA board via serial communication. This step updates the flash memory of ESP32 with both system software and mruby runtime. So basically, the laptop prepares the brain, but this board receives it. That's it. So at the center, we can able to see NARIA board, which is powered by ESP32 W rover B. So now you may ask, why we use ESP32 W rover B instead of the base of ESP32 itself? Because W rover B has more powerful drive. RAM and strong features like dual core CPU, Wi-Fi, Bluetooth functionality, which makes it possible to run on Ruby scripts very smoothly. And also it can support ESP32 Arduino core, so you can write Arduino style type of code also. And FabGL is an graphics and audio library that lets the ESP32 to act almost like a retro style computer. So inside the Naria board, we will be having everything runs in a layer. Excuse me. At the base, we will be having ESP32 hardware. On the top of that, we will be having Arduino core for APIs. Then FabGL will be there, which will be effectively for VGA key. That means visual graphic display and keyboard functionality and audio functionality. Then yeah, Ruby gems will be there for extra Ruby extension. Then the Ruby compiler and virtual machine will be there. Finally, our Ruby user app will be there. This means we can run high level Ruby scripts for logic while still having C++ for performance critical tasks. So, best of both worlds can be performed. So, now let's look at the peripherals, VGA display, yeah, which is connected to through FabGL. So, you can output graphics or user interface. Here, the speakers can play audio directly from ESP32, and micro SD card will be there, which can be used for storing of logs, data, or even a Ruby scripts. And we have PS2 keyboard, which allows real-time user input. So, in simple terms, this tiny board can behave like mini PC running Ruby scripts. So, how it all works together? So, how does everything fit for it? So first thing will be you write Ruby scripts on your laptop, compile and upload them to ESP32 board via Bluetooth, and then on the Naria board, mruby virtual machine will run your scripts, and these scripts will interact with the system app in C++ if needed. In output will shows on the on VGA, sounds goes to the speaker and inputs come from the keyboard, and the storage is handled by micro SD. So in single sentence we can say it as a, these setups will transform entire ESP32 into lightweight computer that executes Ruby code into Ruby code in real time with graphics, audio, and input and storage support also. Next, we'll move on to key features of mruby. So now look at why mruby is so popular in embedded system. So there are five key features will be there that will make it for mruby stand out. The first one will be mruby is lightweight and portable. So the entire runtime can be as small as 100 KB to 500 KB only. That's tiny when compared to regular Ruby. So it runs across multiple platforms from Linux board to tiny or RTOS devices. That means real-time operating devices. This make it possible to bring scripting even into a memory constrained environment. For example, a smart home sensor can run event rules in mruby without eating up very precious space. Second, the mruby is designed to embed directly into C or C++ applications. That means you can write the hardware drivers and time critical parts in C while handling the logic, rules, or anything or any automation in Ruby. So this makes your development to be faster and cleaner too. So since you don't have to recompile your C code for every small changes. For example, in a drone, for example, we can consider just a drone. A flight control runs in C, but a different flight modes like manual, auto, or follow me can be scripted in mruby. So it is much easier to update when we are writing in mruby. So third one will be mruby will support ruby syntax. So ruby is famous for being very readable and beginner friendly, and mruby will keeps that simplicity. Classes, methods, uh, objects, loops, they whatever we studied in C, that will be same applicable for ruby and mruby too. Instead of writing long C loop, you can just write, for example, if you want to print 5 times hello word to be printed, you can say it as just 5 times print hello means it automatically print the 5 times hello statement. So we will see when we will be installing mruby and handling the data. So it will be much shorter and easier to maintain. And fourth one will be mruby is mit licensed. So this is the most permissive license out there, which means you can use it freely in research projects or even commercial products without worrying about legal restriction. So automotive companies like uses mruby for scripting their informant system precisely because of this freedom. And finally, mruby is extensible through something called it's mruby gems. Think of them as plugins. That means mruby gems, which is nothing but just like plugins. So you only add what you need, like networking, math libraries, or file system support. If you don't want anything, you no need to include that. So together, these features make it an excellent choice for scripting in an embedded system. So installing and running mruby from GitHub. So now let's go through how we can set up mruby on Windows machine using WSL. That means that is Windows Subsystem for Linux platform. So don't worry if you have not used it before. I will walk you step by step. First step will be we need to this one will be the first step. So enable WSL. The first you need to enable a WSL. That is basically like installing a Linux system inside our Windows platform. So we can run Linux commands over there. So to do this, open PowerShell as administrator. That means in command PowerShell as an administrator and type WSL and install it. So when you are doing it, by default this will install Ubuntu. Once it finishes, you will need to restart your computer system. So reason for installing Ubuntu here is that instead of running directly in the Windows, is that mruby will build more easily, can be built more easily in a Linux environment. So which provides all sort of necessary compilers and tools. Second, we have to open Ubuntu. So after your PC has restart, search for Ubuntu. Ubuntu in the start menu and open it. Then once it's installed, first time it will ask for username and password. Don't confuse with your Windows login. This is just for Ubuntu alone. So first time it will ask for username and password. Once if you are providing it, so automatically you can make use of it. So already I have installed in my system. So when you once your setup is done system, you can go directly to that. When you once your setup after your setup is done, once your setup is done, you will see imagine you already installed it limited environment. Here the next use case will be Ruby is general purpose dollar symbol will come. So this means we are now inside our that allows Ruby scripts to so it is ready to install via tool and build mruby here. Popular so for installing the tools. So there are 5 cloning the mruby manual, some sort of basic uses mruby compilers and so running these commands one precisely by one. So because of this freedom. and we have to run these as administrator. That means in command. Okay, so this means that you need to type these to build tools and commands. You need to type sudo apt update. So before this, what is happening here is that this sudo apt update will refreshes the package list. So sudo next you sudo apt install build essential GitHub. You need to type and install it. So once this will tells the compiler, that means GCC, and make and gets the entire system. So after this step, we are ready to download and build mruby. So now you can next we can let's grab this mruby source code from GitHub. Next, what we have to do here is we have to type this pseudocode git clone clone and build mruby. So to get cloned, we have to use http github.com /mruby/mruby.git. Once if you are typing it, it automatically get cloned. Next we have to make an directory. So in order to make mruby directory, type cd mruby. So it automatically it will get created. So so I have already installed it. I told you before. So here my username and followed by my system name, $symbol has come. So cd mruby, I'm going to type it. cd mruby. So now you can able to see that now we are in a ruby directory. So if all goes well, this will build mruby. So but sometimes we may get an error while getting into an creating a directory over here. Something like a rack is not installed like that. That's because we need still need ruby interpreted to run build processor. So if you are not getting this, you cannot be able to create this directory. You have to follow this step. So you need to excuse me. So you need to first fix that. So we need to install ruby and rake inside ubuntu. So sudo again you need to type sudo apt install ruby rack -y. So this ruby will tell the standard ruby interpreted and rake a build tool written in ruby, which mruby's makefile depends on. Once it is installed, you can clean and rebuild mruby with make clean and just like make clean and make the directory. So like that you have made a ruby directory and you can made it. So now if you check the screen with the once if you make it out, so you can get version with it. So you now you can type bin/mruby v. So you should see the ruby version displayed. So here mruby version 3.4.0 has been displayed. So here if you are getting this sort of version displaying, so no more errors has been occurred. So let's create a simple ruby script to test mruby and run this command. For example, so cd cd mruby, I'm typing it. So now I'm in ruby. I have created a directory, and then a simple program I can run it. So I'm going to put echo puts instead of input, I can say it as an hello. Hello. And test dot rb. So this will create a file called test.rb with a single line of Ruby code. Finally, you have to run the final script with mruby. So if you are running it, you will get an output like hello. That's it. So if you have successfully installed mruby on Windows using WSL, this is the process we are enabling from WSL. That means installing Ubuntu and getting the build tools and cloning the mruby and installing the Ruby plus rake if required means. Okay, and then run your script. And in the end, you can basically have lightweight Ruby interpreter running inside your Windows, which will be powered by Linux tools. Now we will see some basics, and then we will come back to programming concept. So once if you are done, automatically your mruby will print hello mruby, like that it will print. Okay, so these are all the basic syntax of mruby. Now that we have Ruby will be installed, let's quickly explore its basic data types. So the beauty of mruby is that it uses the, as I said, it uses the same concept of standard Ruby syntax. So if you have seen Ruby before, this will feel like you are familiar with it. And if you are new to this, don't worry, it is designed to be very simple and very readable too. Here, let's start with the variables. In Ruby or in mruby, we no need to declare any data types. You just assign your value directly. So here, if your assigning name is equal to device double colon, inside it I have typed device name, so and count is equal to 10 means it automatically take that integer this to be an integer one, and this is to be an character one. So here the name is automatically a string, right? So and the count is taken as an integer. So Ruby handles the typing for us. This is called a dynamic typing. So what do you think if I'm changing later, count is equal to double colon, instead of in double colon, count is equal to double colon 10, like that I am writing it. It simply it will be changing into string. Next, conditional and looping. Now let's add some logic. Suppose we want to check any sort of condition means, so suppose if a count value is greater than 5 means, you can directly put puts, you can make use of puts here for printing of any sort of value. In a C and C++ and all, we used to have printf for getting on string values. That mean entire commands we used to put it inside the commands, double quotes. Here puts command will be used. So here puts, so double colon high count I have given, and then end. So this will print the high count because our variable count was 10 initially. Suppose if your count will be an 10, so automatically high count will get printed out. Notice how a simple syntax will be here. No curly braces like C or else C++ and all. So we can also loop easily. For example, you can if you want to print anything to more than 3 times 4 times means like 3 times puts looping means it automatically printing looping statement 3 times. So loops are very clean and readable too. And classes and methods. Now let's see something very useful. Ruby is fully object oriented, and mruby keeps that feature. So here everything in the form of object. So we can define our own classes. Here so one of the example is given. So here we defined a class called led. Inside class called, here we defined a class called led. So here led we have we wrote a method. So then we have created an object led inside and called an led on, and called led to be on. So which prints the led on statement on the screen. So this is what this is what makes your mruby both lightweight and powerful too. So you can so we can have two ways to run ruby code in mruby. So using .rb file, that means ruby file, and second one will be mruby interactive cell. So first we'll see, let's see using .rb file. First we can write our ruby code into file, and then we can run it. So first we have to open a new file. So I'll type and I'll execute it. So I'm making cd mruby. So right now I'm in directory. Now you can type anything here. Okay, so I'm going to start from, so nano test.rb. If I'm typing it, I'll be going into an nano platform. So here nano platform, I already I have tried a program. So 3 times do printing the looping statement. Okay, so here you can also delete any programs. So I'm going to write name is equal to device, and count is equal to 10, and puts name and puts count. So if you want to save it, if you want to save it here, you can see a number of helpline here. So if you want to save it, then you can press Control O. It will ask for, then here you need to enter your test ruby file name to write. So it will be showing the mruby. So type enter. So enter means how many lines of you have wrote 5 lines, like that it's shown. Now you just click Control X. Control X, if you are clicking it, you will be coming out coming out of that nano platform. Now you are running that particular program what I typed earlier. So bin mruby. So here test.ruby. So already I have typed name is equal to device and count is equal to 10. That got printed in the screen. So you can also use using mruby interactive cell also you can do this same program. So for that, what you have to do here is, so this is the second way. So when you want to type your program to be one by one, just like that means line by line code typing, just like Python interpreted, this tool will be much more, that means Ruby, mruby interactive shell will be much more interesting. So you start with it by typing bin dot mruby. If it is work, you will see the message called, so sorry, bin dot bin slash mrib. So no such directory will be found here. So if it is, so you can directly make cd, sorry, so you can directly give bin, just type it embedded interactive cell. You will see the message. First interactive cell. So that so bin dot, so if you are typing it, embedded interactive shell will be appearing. So you can type the code one by one, just like it. So bin slash mirb, mirb, not getting it, don't know why. I'll check it out. So once, if you want to type one by one, so one at a time you can type. So name is equal to device. If you are giving it, it will print device, and count, if you are giving it, automatically it print the count. So puts, if you are giving it name, it automatically print the name which got earlier, device. And nil puts count, if you are giving it, it automatically print the count number 10. So here the nil statement is normal, because it simply means that a put command does not return anything useful. It just can print to the screen. So exit from mrup will be much more easier. So when you are pressing control plus D, this that will make your mrip will be coming out of that particular. This sends an end of signal and closes the your interactive platform. Or simply you can type or with the particular program. So embedding next, now that we have seen how to run mruby scripts directly, now let's take next step of embedding mruby inside a C program. So why this is much more important is that because many embedded systems are written in C or C++. Sometimes you want the flexibility of Ruby scripting inside your firmware or C project. So if your mruby is designed exactly for this purpose. So first, just take down this particular example. So here we will be writing the code in C format, so including of header files. So this particular mruby.h will tells the compiler we are going to use the mruby this particular statement will tell you the compiler that we are going to use the mruby library. So here mruby and classes and methods. Now will be, this will create, this particular statement will create a new mruby interpreter inside your C program. So think of it, it is starting up the small Ruby engine that we can feed script into it, right? Next, mruby dot load string statement. This, sorry, this statement. So here, this line will takes the mruby string named as hello from mruby inside C and executes through mruby virtual machine. In this case, it will simply print hello from mruby inside C. So so next closing of mruby, that means interpreter. So mruby underscore close will be, that means ruby has been called. So this will clean up the memory and shut down the mruby virtual machine very gracefully. So when you put all together, it's look like this. So when you compile this particular program and run it, you will see the message like a printed statement like that. The mruby, even though the host program is purely in C. So the main thing is we will be writing a program in C, and then we will be initialize mruby virtual machine and then feeds ruby scripts and execute it, and then finally output on the screen will be shown. So this is very much powerful because you can write some time critical logic in C. At the same time, you can also give scripting flexibility to the developer or user via Ruby. So for embedded system, this means the firmware can stay efficient while behavior can be adjusted by simply wrapping up the Ruby script. So next we are going to run this particular program. For example, if you are driving a car, the car is C language because it's strong, powerful, and fast too. But sometimes while driving, you need some sort of thing to figure out the entire route. So you need some sort of device like a GPS to guide you right. That GPS is our mruby. So it sits inside the car and tells you exactly what you want to do in more flexible way. So I'm going to type this particular program. So nano embedded platform. So embedded, we are going to embed now. So I'm going to keep my file name as embed underscore test1.c. This will open up your window. So here you can write the code as such. So you can include all your header files here. Hash include. So what I'm going to do here is I'm going to just copy paste. So I have copy pasted it. So this nano editor, I have pasted all previously discussed program in. So first we will be opening the Ruby state. That means this one. So this will like starting the mruby virtual machine. Then we will be loading and running the Ruby string. In this case, puts the hello from mruby inside C will be the string. Okay, finally we will be closing the state and end of the program. It's just like switching on mruby and running ruby line and switching off it off again. Okay, so then again I'm going to save it. So for saving of a nano editor, Control O I'm pressing it and then giving enter and then Control X. It will come out of that nano editor window. So once if you are you have done that, you have to you need to tell GCC compiler where your mruby header or libraries are available. Okay, so I'm going to type GCC my file name embed underscore test1.c fn I include l build slash host computer slash library and then hyphen l lm ruby lm and then output the mbed underscore test1. So here I include will here I include will tells GCC where to find our mruby header files, and here lbuild slash host slash library will tell you the path to the mruby compiled libraries. Okay, so lm ruby will link the mruby library, and lm will be much more important because this only links the math functions used by mruby, so it must be at the end. So finally this one will create an output file called embedded underscore test1. So if you are typing it, you'll be getting error. Okay, I just copy paste something I have missed out, I think so. Yes. Yes, so it's okay. So here I have made a mistake. Okay, so next we want to run the program, right? So dot slash embed underscore test. If you are running it, you'll see hello from mruby inside C. So what did we just arrived here is that C gives us the engine power and mruby will make it flexible and scriptable too. So altogether they make a smooth ride for your embedded system. So next we are going to discuss about pros and cons. Now let's take a quick view of advantages and limitations of mruby. First advantage is that it is lightweight, because mruby is designed to run even on the devices with very limited memory, and it will be portable, so you can run the same code across different embedded systems, desktop computers, or even inside another application. And also it is very safe because it is like a sandboxed environment which prevents unsafe operations, which is much more important in embedded system. And also it is very easy to use because anyone familiar with ruby can pick up very quickly. So for example, imagine IoT devices like smart bulbs. So you don't want to want any heavy interpreter to for interpreted for consuming memory. So you just need a small script to turn on or turn off the light. So mruby fits perfectly in this case because it's a lightweight and portable too. So but of course we also need to remember some limitations here. It has only limited libraries when compared to standard Ruby. So advanced functionality might not be available. And another disadvantage is that it is not meant for heavy applications. That means, for example, you would not build machine learning system in mruby. It is optimized only for lightweight control, not for large scale computations and all. So the key takeaway here is that mruby shines when you need simple embedded scripting, but not when you need complex or heavy duty applications. So community wise supported. Next we will discuss how mruby community and support channels will help developers. So first, mruby is an open source project which will be created and supported by max, and who is a father of ruby. That gives a strong foundation. And github repository is the main hub. So here you will find the source code, documentation, and issue tracking, and community contribution. You can able to get it. There are also some mailing lists and forums where developers share tips and debugging issues, and showcase the real world projects. So many third party libraries and bindings were also available. So we would like to thank open source community for providing these many sort of avenues in the open source community. So finally, for those working in industry or commercial projects, a professional support or consulting are also available from contributor and uh, companies specializing in they are specializing in mruby. So whether you are experimenting or learning or building any sort of product, you are never alone. So these sort of community will be always there to support us. So before from the our discussion, I'll conclude that mruby is lightweight and embeddable version of ruby, designed specifically for embedded system and iot applications. So unlike standard ruby, which can install directly using package manager, mruby has to be built from the source code and using the tools like make, gcc, and rake. So the advantage is that mruby will provide simplicity of ruby syntax while also being portable and resource efficient and customizable. And another key strength is that it can be embedded inside c or c++ application, which makes it is powerful for real world applications. And like smart devices and robotics also, it will be very much useful. And overall, mruby will bridges the gap between high level scripting and low level embedded programming. And future scope, looking towards this future scope of mruby, there has been several promising directions. The first one will be IoT and embedded system. So Ruby can act as an scripting layer to quickly customize the devices without recompiling it. And second one will be edge computing and AI. So it can handle data pre-processing and control the task where low latency is important. And third one will be researchers can work on making mruby more energy efficient for battery powered devices. And fourth one will be extending the library and supporting new IoT protocols like MQTT or COPE, or will make mruby even more powerful. Finally, mruby can also play a strong role in education because it is a lightweight platform for teaching programming concept on constrained environments. So, in short, we can say mruby is very small, safe, and powerful to drive the future of embedded system. The future of embedded computing is moving towards lightweight, adaptable. What I can say, lightweight, adaptable one. So wherever, Ruby will be, mruby will be well positioned to play a key role in this evolution. So finally, before concluding my presentation, I sincerely thank the management, principal, and various head of the Department of Chris College of Engineering and Technology Pondicherry for their support. And special thanks to Dr. Tyagarajan sir for giving me this opportunity to share my insights on introduction to mruby and its application. I hope this session would be informative and sparked your interest. So thank you all for your attention, and I would be delighted to answer any questions if you have.
Participants, if anyone has have any doubts, you can unmute your device and raise your questions.
Hello,
Yes, sir.
Madam. This is Virendra from Nagpur, Maharashtra. My question is that what is the role of mRuby in electrical vehicle?
So electrical vehicle is it's a form of embedded system, right, sir? So we have to know the fundamental concepts of mruby, how it will be working for an embedded system. So when you are knowing how it will be working, so you can customize mruby for your electric vehicle too.
No, madam. As per the ATAL topic, it is how it is beneficial for battery management system.
So I didn't get you, sir.
Ma'am, what is the role of mRuby in battery management system?
So that's what I'm saying, sir. So mruby will be much more lightweighted one. So if you want to see, we may have electric vehicle, you may have n number of function inside it, right, sir? So if you want to
Oh,
write all the function in C, means whenever if you want to add any additional functionality inside it, uh, you need to recompile that particular thing again and again. So if you are writing main code in C, and you can compile the small sort of what I can say, small sort of function calling, you can make use of mruby to repeatedly do that particular task.
okay. Okay. Thank you, ma'am.
Thank you.
Any other questions? Okay. Thank you, ma'am. Thank you so much for your valuable information. So it gives
Thank you,
us a
sir.
deep insights regarding the embedded program, how to write a programming in Murbury. Thank you for your valuable session.
Thank you. Thank you, sir. Thanks for the opportunity.
Thank
Thank
you.
you all.
Participants, kindly wait on the call. The next session is going to be started. Good evening. Now I would like to call upon Ms. Silamba C from EC department to give the session to speaker profile.
Now we'll head over to session 2. For this session 2, I am going to introduce the resource person Dr. M. Saravanan, currently serving as a professor in Department of Electrical and Electronics Engineering at IFET College of Engineering. He brings over 19 years of rich academic and research experience. His diverse educational portfolio includes a BE in Electronics and Communication Engineering from Madras University, an MTech in Communication System, and PhD in Electronics and Communication Engineering from Dr. MGR Educational and Research Institute, alongside an MBA in System Management from Madras University. He has published over 30 papers in reputed international journals and conference with topics ranging from low power circuit design to secure automated question paper system and 5G SDNS frameworks. A passionate educator and mentor, Dr. M. Saravanan has received multiple accolades for achieving outstanding academic results in subjects such as analog integrated circuits and VLSI design. He has also contributed as a coordinator, guest speaker, and resource person in numerous workshop seminars and AICT funded programs, imparting training in MATLAB, LabVIEW, Arduino, and sensor interfacing. As a senior member of IEEE and fellow of IETE, Dr. Saravanan actively participates in professional communities. His leadership in organizing technical events, coupled with his involvement in funded research and curriculum development, highlights his dedication to excellence in engineering education, and he stands out as a distinguished resource person committed to nurturing future ready engineers. Now, I hand over this session to the resource person, Dr. M. Saravanan, to start the event about setting up mRuby in embedded system. Thank you.
Thank you, ma'am. Sir, now you can take over the session.
Good evening, Doc. Good evening. Yeah, am I audible, sir?
Yeah, sir, audible and the screen is also viewable, sir.
Okay, sir. So, good evening once again. So, it is a great opportunity for to have my knowledge sharing in this session. So, special thanks to Tyarajan sir and Christ College Management for giving this opportunity. So, in this first day of ATAL sponsored program, so I am going to give the second session. So the second session is given as the topic as setting up mRuby in embedded systems. So I will be taking complete details about just experimentation. Okay. So how mRuby can be used to get your files ready for your any type of embedded system, and here particularly electrical vehicle. So first we will see about our session overview. So first you will start with the introduction to mRuby. Then we go on with the requirements and workflow for setting up mRuby in any type of system. Then steps in Ruby installation. So even though you are going to use mRuby, Ruby is required. So some files are related to that. So we will be seeing about this. Then we will enter into steps in mRuby installation. So how it can be done and what are the source files, everything we will see. The next for these steps we are going to get your open source files from Git. So Git is important and we require that one. So how to install that one, we will see step by step procedure. The next one, additional tools are available. Visual Studio, C tools are required. So this also plays the additional things which is required for any type of programming using mRuby. So to compile the complete code, these all things will is required. So we need this one. So we will be seeing how to install this one. The next one very important. We go for mRuby because of minimum system requirement and lightweight model. So this MSys2, that is minimum system requirement, is very important for compiling. So we will see about this one step by step procedure. Then we will move to I have taken an example. So even though we have seen many examples, controller examples that can be used for your electrical vehicle, I'm going to just demonstrate the basic one for your mRuby file creation and uploading and checking the output using ESP8266. Otherwise, you will say it as Node MCU. Okay. So I'm going to take this example and I'm going to show you how to check it first. So using mRuby, you can compile and you can run it. So before that, you have to know whether your hardware is working or not. So we will see the normal methods. Okay, how USB can, ESP8266 can be checked for uploading the program, so that if you see that it is working, then we can move to mruby and download that file into that one, and you can see whether it is checking. Okay, so for that I'm going to use Arduino Cloud and also Arduino IDE. So Arduino Cloud, those who are not ready to install any programs in your system, and Arduino IDE, so you wanted to download the software and do all the things in your system. So both the things we will say explore it. Then at last you will go for compiling a Blink code for ESP82 using mruby, and at last upload the code and see the output. Okay. So this is the overall system overview what we are going to see in this session. Okay. So starting with the first one, introduction to mruby. So already you listened to the introduction part. It is very compact Ruby interpreter built for embedding C and C++ applications and microcontrollers. And it compiles bytecode using MRPC, which can be embedded directly into the firmware of any type of microcontrollers. So unlike standard Ruby, mruby omits the full standard library. Okay, so you don't need all the libraries for only what is required for that particular application. That alone you can take into account. So that's how it becomes lightweight. So what is the need for this mruby? Okay, so why we go for mruby in embedded system and particularly electrical vehicles? So we are going to slowly explore one by one. So first one is lightweight, minimum memory footprint. So 100 KB runtime. Okay, so that is a very lowest memory among all other types of programming codings for embedded system. The next one, basically C and C++ are the coding which is used for any type of microcontroller. So that is going to be the base which is used for mruby. Then modular, which is nothing but like your library files. So gems, we call it in Ruby as gems, and in mruby MRB gems. So for each and everything, general purpose IO, ADC, for everything we can create your library files as gems, MRB gems, and you can use it for in your program coding. The next one is cross-platform, works across any type of operating system, or bare metal or Linux-based system. So in any type of system, you can write the program, then compile, and at last you can upload it. Okay. So this is why we go for mruby. So here I have given a summary report and a comparison table. So how this mruby differs from other types which is used for embedded system. So in commercial. Okay. So first one is a type. mruby is a lightweight Ruby interpreter, whereas the other languages, Lua or MicroPython or C, C++, others, you can see how they are different. Okay. And memory footprint, you can see the lowest one is this one. Okay. So 100 to 300 KB, very low. And the next one is Lua. So compared to that, here this is the lowest one. So only we go for mruby. And the next one is embedding. How easy you can embed. So using any type of operating system, you can compile the code and you can use it in the microcontrollers. Then the next one we see is syntax. So Ruby like, so those who are well versed with Ruby, it is easily and it is readable. Whereas compared to the other things, it becomes very easy. Then the garbage collection. Here you are going to use incremental GC. So garbage collection is nothing but how the files what is not at all used you are going to manage. Okay. So that is what we call it as garbage collection. So the files which is not at all used can be taken out so that the memory can be freed. Okay. So that is a very important thing in when you are going for a lightweight application. Then modularity, that is the library modules. You are going to use MR gems compared to other one. And in C++, very we know that is libraries and headers, you know, and in MicroPython, Python modules. So like that, we will be using MR gems. So this related, if you want to understand, it is a library file, okay, the complete module file, which can be used in the program or header file. Okay. Then the performance, fast for scripting. Very important thing is how fast you can make the program. So it is fast. with respect to MRUB. And educational value, it is high. How we can say, it is clean syntax and modularity. So the modules and syntax is very simple to understand. The last one, very important. You can see the other applications, particularly here IoT EV control and scripting in the firmware. The basic version itself you can put it in your programming and you can run it. So compared to other one, this makes it MRuby the most possible option for your electrical vehicles. Okay. Now coming back to how to setting up requirements and workflow. So what I have given here is what I have taken and how I have experimented it. I am going to give it up. Okay. So requirement for setting up MRuby. So requirements what I have used is Windows 11 PC and Node MCU or ESP8266 and USB cable to connect it, and internet connection very important to download all the MRuby, Ruby and all associated necessary files for additional programming. Okay. So workflow, how this work will be, step-by-step procedure. So this is what is required. So first installation. So Python is required. So for additional, okay, not necessary. Depending upon the program type and what type of additional components you are going to use and additional applications you are going to use with that, these components will be helpful. So you first go for download Python and you are going to install it. And very important for each and every programming associated with MRuby, the path has to be added. Okay, you have to add the path to the main project file. So add Python to the path is very important. Then the next one, as I said, I am going to show you for ESP826. So particularly I have taken. Otherwise, you can, if you are going to work with 51 microcontroller, you can use it. Or STM, you can use that one. So here I am going for ESP hardware. So I am going for this particular type. So for this particular type to work, I want this one. So install Arduino IDE. Then here a package related to ESP8266 has to be installed. So for that, this particular red color complete syntax has to be added with the additional board manager. As I am not using Arduino, I am going to use ESP board. This board manager details has to be added. So you have to go to tools, board manager, search ESP8266 and install it. Okay. So don't confuse it. I am going to show it step by step. So just for reference, I am showing this one. Then install Git for Windows. So Git is very important to download Ruby or MRuby from your Git file and get it to your workflow. So for that it is required. So I have to download this and install for Windows. Then you in the Git bash, that is command window, you have to clone MRuby. Okay, from the Git you can clone it. Then get into that particular directory. So cd mruby and make. So you are getting your components ready. So this is the three commands, very important. Once these three commands are ready and it is executed properly, you can go for any type of program and compile it into Ruby. Okay. So you can write it in code in any type, C or C plus anything, and then you can compile for Ruby, and then it can be used for uploading to the hardware. So this is the workflow. So the next one is prepare your Ruby script, and this is the for blinking the program, the basic program, having this one. Okay. So this is the programming code, and we know about blink program. So you have to initialize the pin number, which is used blink, and then you have to give the mode whether that particular pin in that hardware you are going to use it as input or output. Okay. So here you are going to use that particular pin number 2 as output. So that pin we are going to write as 1 and 0 so that your LED can be on and off. Okay. So 1 stands for high and 0 stands for low, and the 1 is nothing but high voltage and 0 is the low voltage. Okay. So this is a very simple program. So this is the program which has to be get written for your Ruby language. So how to get compiled? So this is the command which has to be executed in git bash. That is the command window of git. Okay, so bin mrbc, then you go for the particular file name. So here it is blink rb. Otherwise, if you want some other programming, so that files your name has to be good. Instead of blink dot rb, you can give any type of a file there. Okay, so what type of file you have created, that has to be good. This creates a blink mrb compiled script which will be used for. Okay, so this is the process. But if this process has to be run, all these applications must be installed already in your system. Okay, so that is what I mean. So the process step of procedure is very simple, that's all. But before that, you have to download and install the necessary softwares inside, so that everything is executed properly. The next one is create the Arduino sketch with Mruby. Okay, so inside IDE we are going to create. So here you can see Arduino header file is there, then Mruby header file is there, then compiler is there. To compile whatever the program is already compiled, so that will be used for running your program. Okay, so that is going to be used. So here resembles how you can see your output. Okay, so this is similar to your Arduino program. Okay. So the next one, for embedding the Ruby script in the Arduino sketch, you have to have this blink MRB into a object file, so that you can make it as a .c file. Because in Arduino you can upload only C files, but we are having MRB files. So for that, this code is very important. So this is going to convert your compiled MRuby file into an object file, that is blink.c. Once it is ready, then you are ready for uploading the file. So this is the procedure. So the procedure is very simple. So only we are going for. But before going into this procedure, we want to have all the necessary uh, softwares installed in correct way. Okay. So the last step after doing this, you can upload it. So here the ESP is given as by a board name Node MC 1.0 ESP12E module, and COM port according to your system. You have to check it which port it is connected and that port. So once you have selected board and communication port, you can upload the program. Once it is uploaded, you can see the output in your hardware. So this is the procedure. Okay. So similarly, you can go for any type of program. So Blink program. Now what I have shown is a battery voltage. Okay. So you are going to check the battery voltage whether it is above or below the particular. So here two thresholds are given, 3.2 and 4.2. So you are going to get the signal from the battery of the vehicle, and it is going to be given here. Okay, through the sensor it is going to be given here, and if it is high or below this one, so yeah, you can go for any type of alert. If it is low, it can give the alert, and if it is high, you can turn off the alert. Okay, so like that, any type of programming required for your basic electric vehicle, you can write it. Okay, so one is basic program, and this is the program for battery voltage. So check your battery voltage in the electric vehicle in your phone. So I'm not going to get into the programming part. Okay, we are going to see only what is the requirement for setting up your MRuby for your execution. Okay, so first one we go for Python installation. So even though many things have been known to others, those who do not know, I want to make them understandable step-by-step procedure. So only I have given from the basic. Okay, so don't mistake me. So Python. So you search in the Google Python download. So it will lead to python.org. So you go for the first option, download Python. So it will get into this window. So python.org downloads. You go for the latest version. Okay. And here is the problem. So what type of OS you are having? So here you can see Windows, Linux, Unix, or Mac OS, Android, or other. So for each and everything, they have the Python files available. Okay, program is available. You can download and install. So I'm going for Windows. So when you click this window, you will be getting into this window. Okay, so here you can see the thing Python 3.37 August 14 2025. So that is the stable release, latestly released. So if you click that one, you will see separate window where you can details about that particular type of version is given. So slowly you scroll down and you can see the files, what are the different files available. And here I am going for Windows installer 64-bit uh, Windows. Okay, so this is the required file for my system. So I'm going for that. Windows installer 64-bit. When you click this one, you will see in downloads your Python 3.13.7 has been downloaded. Okay. So once you are downloaded, any type of program, not only this program, any type of program when you are going to install, you have to go for this option. Right click, go for run as administrator. It is very, very important. Then only you will get all the administrator privileges to install all the files in the software in your system without any error. Otherwise, it may do not get administrative privileges, so some files may be taken out. So have that in your mind. So any type of software when you are installing, you must go for run as administrator so that the program is correctly installed. Okay. So you go for run as administrator. So you will be getting into the Python installation thing. So you can see customize installation or install now, and this is the normal type. Usually you go for install now, so you can click over it. But if you see for mruby, it is an not a Windows based one. It is a Unix Linux based one. So you have to have path for each and every uh, associated files to be linked with the original main program. You have the path has to be linked. So this is very important. Add python.exe to the path. So all the softwares, whatever you are installing, path has to be added to the main program. Okay. So add python.exe to the path. So you have to click that one. Then you can go for install now. So once you view install now, it started installing all the files in your system. So once it is installed, you can see this is setup was successful, and you can see disable path length limit. There is one option available. So this is very important for Linux based system. So 260 characters. So now as you are going to use different types of files or different types of paths from various softwares in your system. So this may be a problem when you compile the original mruby. So go for this option, disable path length limit. So when you click that one, you can disable it. Now you can close it. So now Python has been installed. So the next one is whenever a program is installed in any system, you have to check it whether it is correctly installed. So you have to go for that procedure. So for checking whether this Python has been installed correctly, we have to go for command prompt. So go for search. In that you go for CMD. You can see the command prompt. So get into that one. So you will be getting this command prompt, and here you go for type Python hyphen double hyphen and version. So when you type this, it has to return this line. Python 3.31. So what version you have installed, it has to return. So when it returns, that means your system has been correctly installed with this particular software. So here it is Python 3.13.7. So you got the first software installed. Okay. The next one, Ruby. So we are actually going to use mruby, but for that, important library file is associated with Ruby. So installing Ruby will be helpful for you. Okay. So what is the requirement? What is the steps? We are going to see one by one. The second, software installation. So introduction to Ruby programming language. So Ruby is a dynamic open source programming language for simplicity and productivity. So we are not getting into this type. I'm not going to explain about this language. Okay, so we are concerned about installing. So these details will be given in next sessions. So many sessions are there. So you will be seeing more details about this one. So the first one, download the Ruby installer. So you have to get into the official Ruby installer website and get the latest version. and download it. Okay. And once you have downloaded the executable file in Windows system, you double click that, accept the license agreement, and so here also the very important thing is this, add Ruby. Okay, so this is very important in mruby. Otherwise, whatever the program you write in mruby, you cannot compile. It will be asking the files or the command is not available. Okay, so you must be very so is the next one. What is required with this is MSys2. So MSys stands for minimum system. So for lightweight comparison, what is required? So you have to install this one. Okay. So you have to download the software and go by the instructions on the screen. Okay. So this is a very important thing for native extension and using gems that require C++. Then verify the installs. So whatever the software you are going to download and install, you have to verify whether it has correctly installed or not. Okay. So in the command prompt, you can check the version. So once you have installed Ruby version has to be displayed. And the next one is you have to see the gem version, that is package manager for Ruby. So after installing the program, you have to check it whether it is working. So for that, you have to open the text editor. Okay. So you have to open any type of text editor. So here it is notepad. I'm going to use a notepad. Write the following code. So any code. Here it is given Ruby, puts hello Ruby. So according to the syntax of Ruby, it is given. So once you have typed these contents in a notepad, save the file as. So you have to go for save as option. You must not go for save option. You have to save as, and you have give a name. .rb is very important for Ruby files. Okay, so here it is hello.rb. In command prompt, navigate to the file location and run it. Ruby hello rb, then you will see the output. So what is in that file? It is just put hello Ruby. So you will see the output as hello Ruby. That alone will be displayed. So you will see how this is done. Okay, and file mode is there, and the next one is interactive Ruby mode, IRB mode. So you can get into this also, and directly you can give the input, and immediately you can see the output. Okay, so you will see. So you have seen the steps. Now I am going to show how the original things will happen as a step-by-step procedure in the coming Windows. Okay. So you go for Google and search for Ruby download. You can see the first one, Ruby programming language, ruby.language.org downloads. You go for that, download Ruby. So you will be getting into this window, Ruby main programming window, that is main website window. Then go for download Ruby. Okay. So here you can see many versions are there. So you have to check for your latest version and what type of system you are having. 64-bit means 64. So here you can see Ruby Dev Kit 3.4.5-1 into 64. So this is the file required for myself. Okay. So with the development kit is the requirement. So I go for this option, Ruby plus Dev Kit 3.4.5-1. Okay. So this version I'm going to download. So click that one. You can see in downloads that particular Ruby software has been downloaded. So once again the same procedure. Whatever the program you are going to install, you have to go for with run as admin. So right click over this one and go for run as administrator. Okay. So very important thing. If you forget this one, some of the options may not be allowed. So while you are comparing that, you will create a error. So you do not know what is the error because where the problem is. So it will take a long time to debug. Okay. So once you run as assembly, you will be seeing this window. So you can use it for If your system consists of many users, you can install for only yourself or for all the users. So I am going for myself. Then you can see the next window. So here you have to give the accept the license. The next very important files once again in mruby while you are compiling, you will get into error. You can't execute the complete thing when the path is not correctly included. So you have to see add Ruby executables to your path and associate .rb and rbw files with this Ruby code. So both the things has to be checked. So make this very important. Okay. Then go for install. So you will be getting what type of things will be installed. So you will get the base file, then RI and HTML, and your minimum system to development tool chain. Everything will be installed. Okay. So now it is getting the files from your software that is downloaded, and it is going to install it. So once it is installed, you must get this setup wizard. So completing the Ruby setup wizard. So everything has to be installed correctly. So now you can run this one to get your MSU. Okay. So run RIDK install. So when you check this one and give finish, automatically you will be getting into MSys2. So MSys2 is minimum system 2. Okay. So you go for finish. So like I said, you have to check it. Okay. So this next one is as the last window shows, you have to install the MSys. It is asking three options. So you can go for all the three or any one depending upon what requirement you have. So I'm going for all. So it is going to get the files from the internet. So the starting itself, I have given requirement internet is very important. Depending upon your internet speed and internet availability, this will be downloaded in a fast manner. Otherwise, it will take some time. Okay. So you must be making sure your internet is with good speed, with good signal quality. So once you have completed uh, executing this one, you can see uh, install sys and mg development tool chain is succeeded. So you have to see this one. So succeeded means everything has been correctly installed. Okay. So this is how you get your M6. The next one you are going for checking mode. After installing, I will go for checking mode. So you have to type command. So cmd in your set, and you can see the command prompt. So getting into this one, state Ruby version. Okay, you are going to check whether the Ruby is installed and what version you have installed. So Ruby hyphen version will show. So Ruby 3.4.5 is installed. Okay, then gem, that is your package manager. So what version? So the version is 3.6.9. It is also available. So now you have all the requirements Ruby for your Ruby software is ready. So you can check for executables. So here given a command puts hello world. So it is executing that. Just printing hello world. And the next one is interactive mode. Interactive mode, instead of writing a file, then compiling and showing the output, you can directly enter any input here. The answer will be given immediately. So that is called interactive Ruby mode. Okay. So go for IRB. So you are getting into IRB main. So you can just I am typing 2 plus 2. Immediately it gives the answer 4. Okay. So it is of that type. Then the next one, I'm going to try some of the statements. So I'm going for making a file and using that file inside my command to execute it. Okay. So I'm getting into Ruby where the Ruby is installed. In there, I'm going to create a text document. Okay. So just to create a text document, and inside it, I have just put welcome to the FTP. Puts is the syntax, and within the double quotation, whatever you write, it is going to be executed. Okay, so just a simple thing so that you can see. Okay, so now you have to go for save as, file save as. So you can see file save as. In that you have to write the name within double quotation and go for all files option. Okay, save as type all files, and here you have to write hello dot rb. So rb stands for Ruby file. Okay. Then go for save. So you can see that hello Ruby file. Okay. So once a Ruby file is inside, I can get into this uh, command prompt and I'm going to uh, Ruby hello data. Okay, so this is the name of the file. Hello dot rb is the name of the file what I use. So once I execute it, what is the contents inside is executed and I can see the result. Welcome to the FD. Okay, so very simple. So any program, any type of program you want, you can write it in a text document, that is a notepad, then save as a Ruby file. You have to save as in within double quotation, you have to give the name. Okay. So whatever the file you name you need, dot .rb is very important and you can save it. Then you can execute here, you can get the output. Okay. So this is how the Ruby runs. The next one, the main mruby. So here two different things of installation is there. One is using your command prompt, you can clone the git. Okay, from git file you can clone it. Otherwise, directly you can download. So first I am going to show how to go to the particular window, that is website, and download your mruby and get into that. So first you have to go for GitHub com mruby releases tag 3.4.0. So you have to get into here and go for the source code zip file. Okay, so when you click over that, you can see your file. Okay, so I given the complete path here below. So this is the path you have to use it in the Google Chrome and get your mruby source code. Okay, so that file, when you download, it will be available in downloads. From here, you can go with execution path. So other one is you can clone it. For before cloning in Windows system, you have to first install the Git. Only when you install the Git software, you can use this Git to clone any type. Okay. So how to get the Git software installed in your Windows 11 PC? So that is the step you are going to see. Okay. So you have to search for Google Git. So that is you can see git.scm.com. So Git is nothing but a free and open source distributed version of control system. Okay, designed to handle everything from small to very large projects. Okay, so you get into the first option Git. So you can see this is the window where it will lead, and you can see the latest source release as 2.510. So you can have for any type of operating system. I am going for download it for Windows. So when you get into the Windows, you can see x64 setup, standalone or portable. So portable means you don't need to install. You can have it as a in your pen drive, any type of usable device. Okay, a portable device, and you can just whenever you want, you insert that one. From there, you can work it out. So now in the system, I am going to install it and work. So I am going for the first one, Git for Windows x64 setup. Okay. So if you click that one, you will be getting downloaded. So you can see that window, Git 2.5.1.0 bit has been downloaded in the download. So the same thing, any software to be installed, you have to right click and go for run as administrator. Okay. So go for run as administrator. So we'll be getting into this window. Go for next. Then go for where you have to install that. Then very important is how the files are going to be ready for your mruby, how it can be used. So here the additional options, whatever is required for you as per your user experience, you can go it. Okay. So check all the icons, whatever is required for you, and make it check. So I'm going to go for additional icons. That's all. I can go for next step. Then where which folder you want it, you can get browse and get it. Then go for next step. Then add another dependables, whatever is required, so that all will get into that one. Okay. So go for next. Name of the initial branch. for new response. Whenever you are going for a new project, how it has to be. So I go for let git decide if you want master as the name. Otherwise, you can go by your own name. So usually main for overriding. So either you want master as the main the root file, or you can go for some other names. So master is one type, other one is main. So you can use it anything. I go for main. Then we have adjusting your path environment, very very important when you are going to use it with third party softwares. So you go for the second option, git from command line, also from third party software. Okay, go for this particular option and go for next. Then choosing the SSH, so secure shell, very important. Use bundled one or external, so you can go for bundled one. The next one, where you are going to use, I'm going for Windows because the Windows system, I go for native Windows. And the next one is what type of system you are going to have, configuring the inline conversation. So as I'm going for Windows system, I go for the first one. If you are going for Unix or some other, you can go for other option. Okay, so I go for Windows type. So first option is West one. The next one, you need mruby. Mruby msys is very important. Default terminal, like for your Windows, CMD is the terminal. This is the terminal. So use that one. Then behavior, default behavior for your git pull. So I go for the first option, fast forward. Then credential helper manager. So what type of manager you are going to use? I'm going to use the first one, git credential manager for cross platform. And extra options whatever you need for you. So here enable file system caching is required. Okay, so whatever the files you are going to add, it has to be cached. So all these options is given, then you can see your program that the software is installed in program file. So once it is installed, you will be seeing this. So completing the git setup, and you will be seeing launch bit bash and view resource. So git bash you can launch and you can verify it. Okay, so you can exit now. So once you go for your git bash, so this is like your command window. This is the window for. So here I want to check it whether it has been correctly installed. So you are going to initiate your git. That's all. So once it is initiated, you can use it for your any kind of application. Okay. The next one git is ready, then you can go for cloning your mruby. Okay. So for that, this is the command git clone https github.com mruby.git cd mruby. Okay. So actually this is the code up to mruby.git. Then you, after cloning, you have to get into that particular directory cd mruby. Okay. Then after getting into that particular directory, you have to build that. Okay, whatever files are inside, you have to build it up completely. You have to build it. For that, the command is rec. Okay, so this is how you have. So you have got git
Let's
command
see
window. You have got
something very
into.
useful.
So there, I
Ruby,
given the first command git clone https, and where this mruby is available. So once you are given, you can see it is connecting by internet to that particular website, and it is cloning. The complete files has been getting here. Okay, receiving this. So once you have, then you must be seeing 100%. So once you see 100%, it has been ready. So your mruby has been downloaded into your system. Okay. Then you are getting into that directory. So for that you have to use cd mruby. So now you got into mruby. Okay. So once you are mruby, then you can go for scripting all other things. Okay. So now I'm going to relate it with your EV battery management. What is the topic of your ATAL? So here, uh, battery management. So what are the things you can do and how your mruby is good. So you are going to create the gems for cell monitoring. So that is the battery package will have many cells inside. So each and every cell can be individually monitored. And the next one is balancing control. So using your resistive loads, you can do that one. Then SOC estimation, that is uh, charging and discharging, that is coulomb counting, very important for battery. And the next one is thermal management. So what is the temperature, and responding is very important. High or low, accordingly you have to respond back. Then the last one is communication, how your files, whatever the commands you are sending, how it is transmitted to your management, other management software, otherwise from the management software to the cloud where you can monitor it. Okay. And the last one is safety cutoffs. So prevent overcharge, discharge, everything. So this is the functionalities, and this is the module, this is the functionality, and how your mruby role plays the vital role there. So you are going to have a controller. So the controller, for that controller you need a coding, a programming language. So there interfacing your general purpose input output plus ADC. So using C programming, you can do that. Then the next one for balancing control, that also you need some inputs through general purpose input output. So toggling, changing input output, you can use this one. Then uh, tracking your how much has been charged and how much it is discharged. So that also logic, you can implement the logic to see the battery discharge and charge. The next one is monitoring temperature. Temperature sensors can be interfaced with the controller, any type of controller. So I'm using a basic ESP controller, whereas you can use 8051 basic microcontroller, or you can go for STM or any other things, ARM based microcontroller, any microcontroller. But basic thing is you have to interface it by your mruby coding. Okay. Then similarly, for communication, UART, universal asynchronous receiver transmitter, and I2C or SPI. So otherwise HTTP via Wi-Fi. Okay. So any types of communication, that is you want the complete information about the battery in your dashboard or in your mobile or anywhere where you are going to monitor. So for that it can be interfaced with any type of communication modules, for either it can be internet or Wi-Fi or IoT, anything. So for that also mruby programming can be used. So using your mruby, if you program, the memory space requirement is very less. Okay. And the last one is real-time checks and interrupt. So whenever the system has to be started, that is management, battery management has to be started, you can go for real-time check whether it charge is full. Each and every cells has been charged, a particular cell is not at all charged, whether it is faulty, everything you can note it down. So depending upon how it is programmed with the controller and how it is executed. So this is why mruby scripting is used as a base one for your electric vehicle. So here the architecture, the basic architecture in the battery management, how many cells. So depending upon the lithium ion or any other type, how many cells are inside your complete battery. Okay. So you have to see on what type of interfacing has to be used, so that it can calculate whether it is charged or discharged. Okay. So that particular sensor, you have to see what type of battery you are going to interface it. The next one, microcontroller, very important. Without a controller, you cannot do anything. Okay. Without controller, you cannot execute or monitor, or you can check. Okay. So alerting is very important, because it's a electric vehicle, on the way if it something happens, nothing can be done. So you have to check it in the real time mode. So this is required. So any type of controller can be used. I am going to show the basic programming in ESP8266, and otherwise you can go for STM32 or Raspberry Pi Pico, everything which has mruby support. Okay. And for each and everything, all the header files has to be made it ready. Okay, what we call it as MRB gems. So you have to design according to the hardware what you are going to use. Okay. So what type of that means the header file will contain what voltage is required and what is the frequency, what is the timing, every information. Okay, and the next one is coulomb counting, very important, charging, discharging, and refined with Kalman filters. Okay, so these are the details what has to be known before programming a electric vehicle battery management system. So next, very important thing, why we go for mruby, we have lots of libraries available. So now I have shown. So choosing a particular microcontroller, in that microcontroller, what type of MRB engines, that is the libraries you are going to use. So for each and every microcontroller, the particular, for example, ADC or interfacing a general purpose IO or a timer, everything differs. But programming, that is designing that library file, is a typical task. Okay, very complex one. So it may be somewhat difficulty, but as it is a open source, many things has been already done. Library files has been created by open source contributor, so which is available here. Okay, so you have to go for mruby.org libraries. You can see lots of libraries are available. Okay, so any library which is you needed, you can just click over that one, and it can be downloaded and it can be used in your file management system, so that it can compile and you can execute it. Okay. So up to now we have seen Python, we have seen Ruby, then we have seen Git, then MSys, then mruby. Then the next one what we are going to see is additional requirement, Visual Studio C++ tools installation. Okay, so this is very important for making the program. Okay, so lots of editor is there. This is one type of editor. Okay. Instead of notebook, you can go for Ruby. File can be opened in Visual Studio tool C++ tool, and you can edit it and save and then go for the next. Okay. So how to do that? So we are going to see this step-by-step procedure. Okay. So first one, you go for Visual Studio Microsoft.com, Visual C, C++ build it. Okay. So you can go for this one. You can see this window. In this here, you go for download build tools. Just click that, and you can download that. Okay, so same procedure, don't forget, whenever you are going to install some software, go for right click, run as administrator, to get all the administrative privileges for correct installation. So go for run as administrator. So once you click that one, you will be getting into that package. So go for continue. So it is going to download the files and going to install. Okay. So you must see this green and tick mark. So all the files have to be correctly downloaded and installed. So only said you need internet. Without internet, so all these files are required for only one time. So have that in your mind. Why I have to go for this lots of software installation? This is one time installation. You say no capital installation like that. It is one time installation. Once you have installed, then your work is only to create a file with the program, compile it, upload. That's only three words. Once go for a notebook editor, open it, write the program, then compile, then upload to the. Okay, that's all. Okay. So before that, you need all these dependencies. Okay. So once it is installed, you will see this window. So in this window, we have different environment available. So it will be used for what type of applications you are using. Okay. So we'll be getting into installer mode. So downloading and verifying all the files and packages. So totally you will be seeing 20 packages must be downloaded and installed. Okay. So once everything is installed, you can get into the next. Okay. So you can go for modify launch channel. So once you have installed, you have to go for launch mode. Okay, for checking. So this is the launch mode. You can see you got into the C program files, Microsoft Visual Studio build tools. Okay, so your Visual Studio build tools has been successfully installed and it is in the file. Now this MSys installation is a peculiar installation compared to your mruby what already is done. Okay, so you will be getting into this episode. So individual, that is a dependable. This is a individual. So you go for this particular msys2.org. Go for this one, and here you can see that download the installer. So either you can go for 64-bit or 32-bit. You go for I'm going for 64-bit. So once you download, you can see the file has been downloaded. Then once again the same type of instruction, run as, right click, go for run as administrator. Okay. So the next one, build it. That is installing in the particular folder. So go by the default one. Next, unpacking the components, install. So now you have to check it. Okay. Go for this particular option, finish. And in search you can go for Windows PowerShell. Okay, search for Windows PowerShell, run as administrator. So this is where you can check whether your MCC has been installed correctly. So this is the window you will be seeing. So here I am going to have these commands inside for execution. So once you try, you are going to get a particular another dependable software file for compiling, that is called chocolatey. Okay, so this is once again a requirement, additional requirement. Okay, not requirement, additional requirement, depending upon the files what you are doing. So all this, when you install any kind of program, you can compile. Okay, so I'm going to use this one. So once you install, you will be seeing this window. Okay. So once install, you can check the version. So it is showing as 2.5.0. Okay. Next, from search, you go for MSys2. So this is the command window of this minimum system 2. And here you can see the basic command line. Here I'm going to install make, that is building the components what has been installed. So once you build, then only you can use for compiling. Okay, so that is the requirement. So I downloaded and I have installed it. Okay, so once you have installed, you can see your clone mruby and you can see the output. Okay. So this is for upgrading the package, and you can see the complete system is upgraded. So this is the command pacman. So this package manager -syu. Okay, system upgrade. Then for compiling purpose, you have to go for package manager a base level min w64x86 GCC. Okay, so this GCC is for your testing mode. So the packages will be downloaded and it will be installed. So once you are done, you are ready for compile. Okay. Now the additional thing is you have to go for adding paths. So whatever you have installed, you can. So for adding the path, you have to get into the system environment variable. So you go for edit the system environment. So in search, you have to go for edit the system environment variables. Where you have to go? In search, you have to just type edit the system environment. Just you put edit, you can see this particular option available. When you click that, you can see this one. Okay. In that, you go for environment variables. Environment variables. You click that one, you can see user variables for that particular user and system variables. Under system variables, you can see there is a path. So this path is very, very important to have all the accessory files get into your main source code. So there you just check path. Under path, you go for new. Okay, just select path and go for new. So it will be asking variable name and variable value. In the variable name, you give path. Okay, and variable value. So you give where your system, what software has to be linked. Okay, so that entire path has to be given. So here, this is the path for your adding the path of MSys. Okay, so see, you can have this link. Okay, so once you are given, click OK, then that path will be added. Okay. Now coming, all the accessories has been installed successfully. Now I am going to check it for my hardware, a particular hardware ESP826. So embedded controller ESP86, I am going for checking. So what is the requirement for this checking? So even though we have many modules of ESP, I am going for particular controller node MCU. Okay, node microcontroller unit, which has Wi-Fi and everything, so it can be easily used for electric vehicle management system, where it can get the sensor readings and it can give it to monitoring Wi-Fi using Wi-Fi. So I'm going for particular thing node MCU. Okay. So how it will look like? This is the board, very simple board, around 300 rupees. Okay, and you can see various interfacing pins available on both the sides. Okay, so this board, uh, internal dependence, what all will be available. It is a microcontroller. We know what is the difference between microprocessor and microcontroller. Microprocessor only can contain CPU, whereas microcontroller contains of CPU along with that all kinds of RAM, ROM, and timers, and IO ports. Everything will be available. Okay, so here in your 8266 node MCU, this is the component. All these components are available for easy communication. Okay. So in detail, it is given. So we are not getting depth in explaining the microcontroller. Okay. So how to test this one? Okay. So I have already said I am going to test it first by normal mode, then go by mRuby mode. Okay. So for normal mode, whether your board is working or not, first I want to check it, because after writing a very large project for electric vehicle management, then compiling, and when I download to the microcontroller and I see where it is not working, it is useless. Okay, so first I want to check whether it is working. So for that checking, I'm going to use this method. Okay, install Arduino IDE, go for ESP8266 board, and in that you go for file preferences and you have to add this command. So using this command, your ESP8266 board manager details will be getting it. Using the board manager, you can get this detail and install it. Okay. So what is the step? So in Google, you search for Arduino IDE. Arduino IDE. Just a second. Yeah, sorry for the interruption. So you are getting into Arduino IDE. Okay, search for Arduino. You can get into the first website Arduino IDE. So get into that. You can get into the software where you can download. So Windows 10 or newer version, you can download it. So go for Windows 64 and download it. Okay. Now here you will be getting another option in that website is cloud. Whether you can use it cloud or you can go for install version. IDE. So IDE stands for Integrated Development Environment. Okay. So that we will be using in the system. Now I go for Arduino Cloud. How to check your ESP board in Arduino Cloud? So you'll be having scroll down. You go to the cloud editor. So it will ask you to sign in. Go with your Google ID or any other ID or create an account. So once you get in, this is the window you will see. Okay, cloud, Arduino cloud. So once you get into this one, you are going for add device. Okay, so you have to add this particular device. So go for add device. So it will be asking Arduino boards or any other compatible device. Arduino boards or any other compatible I'm going for compatible. I'm not going to use for Arduino board. I'm going for compatible device. So when you click that, it will be asking many devices are available. So popular one is ESP8266. So I go for select that one. Okay. So once I have selected, and particular in that particular module is Node MCU 1.0 ESP12. Okay. So I have to go for this module. Okay. So I have selected that one. Okay. And for this device, so in a project we will be having many devices, but in my this project I am having only one device. So I'm going to give you a name for that one. Okay. So once a name is given, you are going to set it up. So the next one in the cloud, to have the data through Wi-Fi in the monitoring cloud environment, I need the device ID and secret key. So this is required only when you want information to be sent to cloud and you want to visualize by Wi-Fi and internet connection is available. Otherwise, this is not required. But you need this device ID and secret key in the program to get the real-time data to this cloud server. Okay, so this has to be downloaded and you must be saved that. So I can download this one and I can save it. Okay, then continue. You can get into so you can see devices, my Ruby demo, and URL. It is in offline because I did not connect anything. Okay, just I am getting into the program. That's all. The next one, you have to create the sketch. Okay, programming. So go for sketches, create sketch. Okay, first device is over, then go for create sketch. So when you get into your new sketch, select device. In which device, Arduino board or any other board, you have to select that. Then only you can do the correct programming. So select the device. So for that, you have to go for device. Okay. So when you go for this option, select device, it will be asking to download this cloud agent. Okay. So this agent is important for connecting your hardware with the cloud. Okay. So you have to go for download and download the file, then install the file, same thing, run as administrator, step-by-step procedure. So once you have install this one, okay, accept the agreement, go next, install it. Okay, so once everything is ready, you can see that file will be shown here. Okay, so connecting my hardware component, so it is in COM8 port. Okay, hardware has to be connected. Once it is connected, port will be known. Then you can select the device, unknown device, what type of device it is. So what type of device? It is ESP12 module. Okay, so in that you go search for Node MCU, Node MCU 1.0 ESP12 module. So that is the particular series what you are going to use it. So once you have selected, you can see the device is shown here and you can go for the programming. So this program is from anywhere, you can copy and paste it or you can type it here. Okay, and I'm not going in that. Otherwise, you can go for built-in programs. In that, Blink is available. So from there also you can take it. Okay, so you can see this left hand side. From the examples, you can go for built-in. In that, you go for Node MCU, particular type of hardware. We have the basic programs. In that, you Blink. So that program you can upload. Okay, so once the program is there, you can see this option. The first one is for compile, second option, this arrow mark is for uploading. Okay, so when you click that, it will be verifying. Then it can upload, console uploading. You can see the statements below. So it is writing into your hardware. Okay, 31%, 32, like that it will be going on, and at last it has been completed. Done uploading. You can see that done uploading Blink program. Okay, so once it is uploaded, you can verify your hardware. So here I can see once programming and output, both the things I have recorded just to understand. So you can see. So now it is programming. Okay, program is entering inside. So it is blinking. Okay, it is programming. 35%, 40%, like that. It is programming. So once the program is completely uploaded, you can see that LED blinking because you have uploaded a Blink program. So after completing, you can see inbuilt LED is blinking one by one, blinking for 1 second. Okay, so this is how you can check it with cloud. So the next one is using IDE. So cloud, no need of installing any software, Arduino software. Directly you can upload and you can see the output. Okay. The second type is you have to download the software, install in your system, and then you have to program, upload, and you can see the output. So what is the procedure for this? Basic understanding of ESP8. Okay. So you download the software from that website, Arduino IDE. So this is the software. So the same process, right click, run as administrator. Okay, then uh, run for only me and browse the location, destination, then it will be installed. Then you can check this box so that your ID is ready for uh, programming. Okay, so this is the main window. So this is most of us Arduino main 4. So once you open that, will be downloading the necessary packages. So here, what is the process? Already we have given the steps. So the first step is you have to go for file preferences. File preferences. In preferences, you have to give this. Okay. Preferences, additional board manager, you have to type this command. So the command I have given already in the PowerPoint. So this is a common one. Okay, everybody know who are using this ESP board. They know this is the common thing. Okay, so by using this, that particular package details or what you say uh, specifications, every details will be getting into your Arduino. Okay, then click OK. Then you go for tools. In that board, go for board manager. Tools, board manager, and here you have to type ESP82. You can see that particular thing. Go for install. Okay, board manager. You can search ESP8266 and you go for install. Okay, once you give that option, you can see the files are packages are downloaded and installed. So for this also, internet is very important. Without internet, you can't complete these steps. Okay, so internet has to be there. So this is also a one time checking procedure. Okay, only one time you have to check whether your hardware is working or not. After that, you can directly go for MDB files, write the program, compile, execute. Okay, upload. Right. Okay. So you are downloading this. Once it is downloaded, you can see. Uh, you can see after install. You can see only the option remove will be available. So now you are ready for programming ESP board, okay, in a Arduino IDE. So now go for tools, board. In that board, you go for Node MCU 1.0 ESP12 module. So that is the particular module what I am having. So go for that module. Then go for once again tools and port. Go for uh, port which is connected to your hardware. So whenever you connect your hardware to the microcontroller or any other hardware to the system, a particular communication port will be connected. So you want to know that. So here you can see many ports are there. I don't know which port is connected to my ESP board. So how to check that one? So usual procedure, many of you do know, but I want the basic to be known to everybody. So to check which port is connected, my hardware, when I connect to the system, which port it is connected. For that, what is the procedure? You have to go for device manager. In Windows, you search for device manager, click that. You can see all the hardwares connected to your system will be seen here. In that, you have to go for port. You have to go for ports. When you click that, you can see different ports are available. In that, you can correctly see USB CP210X Silicon Labs is connected through COM8. So this is my UART bridge. So this is the actual connection which is connected to my ESP board. Okay. If you want, if I have connected more than one board, you can just disconnect and connect it. If you disconnect, this particular thing will be disappearing here, and whenever you connect it here, it will come here. Okay. If you are having more than one boards, you can check like that particular board which communication port it has been connected. Right. So it is a communication port 8. So I have to connect it to COM 8. Okay, so once you know here, you are once again go for your tools port. In that you go for COM 8, communication port number 8. So now you can see controller is connected, port is also connected. Okay, now I am going to write the program inside. So this is my program for your LED, my ESP board. Okay, so once I have written this one, once I have written this program, I can go for compile and upload it. Okay, so you go for compile mode, that is then upload, and you can see compiling, and it is writing the entire program inside. Okay, 8%, 16%, like that it goes. Once everything is written, you can see this output. Okay, so this is the after 100% uploading program, you can see. And here also I have taken the video of the output. So now it is uploading the program. Whenever uploading the program, you can see this particular LED, and the same LED is going to blink here according to the program what I have uploaded now. So instead of this LED, I'm going to have this LED blinking according to the program what I have shown. So once uploaded, you can see this LED is blinking. Okay. So this is how you can check the hardware whether it is working by using Arduino ID. Now the process is over. What I have done, I have checked my microcontroller whether it is working in normal mode. Now I am going to go for mruby. Okay. So compiling blink code for which, so all the procedure has been given. Okay. So if you follow that procedure according to the installed program, you will be seeing uh, in documents Arduino libraries inside this project file. I have created mruby underscore esp8266 underscore full project file. You will be seeing three things. One is examples, one is src, one is library. So these three things must be ready. If you follow all the software installation and execution of the commands, what have been given as steps. Okay, step 1, step 2. Okay, so what will be in the examples? So you will be seeing this blink. So blink is actually the program which we have typed in a notepad and then you have post. Okay, so that is actually copied to Arduino based upon this. The next one in the SRC, that is source files, you will be seeing C blink source C file. Okay, so that is from Ruby, it has been compiled to C. And for executing your mruby, you have mruby underscore core, a C source file, and in the program to use it as a header, we have header file. So these files will be automatically created when you compile. Okay, so these are the requirements must be available. If this is available alone, we will be able to execute the commands. Okay, now uploading. Once this is ready according to the previous steps what I have already given, if you installed all the necessary things and if you are following the step 1, step 2, step 3, you will be getting these files. Once you have done, you can upload the code to ESP. So for this I am going to do it in real time. So for that what you have to do, you have to go for your desktop Arduino ID installation. I'm going to open that one. Okay, and in the meantime I'm going to connect my hardware component. Okay, so I think you can see this hardware component is available, ESP 8266. Just I'm connecting it. So when I connect it, whatever the program you have done already, it will be starting running. So that is the special thing of microcontroller. So you can see here, already I have given uploaded a program which is blinking very fast. Okay, now I am going to change this program. I am going to change this programming. So already I have compiled and this particular file for ESP I have given in the added in the examples of Arduino. So I go for file examples. In that I am going for ESP 8266. Yeah, scroll down, you can see mruby. So other things you would have seen in those who have worked with Arduino, you would have seen the other things. So above things will be available in normal, whereas when you have done according to the steps what I have shown, download all the necessary softwares, install it, and you have executed, you will be seeing this mruby underscore ESP8266, and that blink program has been compiled. So I'm going for that one. Okay. So now it will be opening. Okay. A new sketch file. mruby based blink file. Okay. So that is opening slowly. It is opening. So depending upon system, how many applications are running, it will take time. Okay. So I'm going to expand it. So I think you can see that. So this is the program which has been. Okay. So you can see Arduino H is there, mruby core H, blink C is there, then mrb gems, everything has been initiated, and built-in LED high low. 1000 milliseconds has been given. That is for each and 1 second. So here it is blinking very fast, but what the program I have written is for 1 second. Okay, it will be blinking for 1 second. So it has to change. Okay, so now I go for tools. So board. So we know that is a ESP board. In ESP boards, you have to go for node MCU 1.0. Okay, so it has been already selected. Then you have go for port. Very important. Communication 8 port. So to check it, what you have to do? You have to go for uh, device manager. In device manager, you can see your COM port which is connected here. So all the components will be listed. I think you can see. I'm going for ports. In that you can see silicon version. Okay. So here only I told if I disconnect it, if I disconnect from the system, so you can see this particular COM8. You can show that will be disabled. It will be not available. So I have taken out. You can see it is refreshing, and you can see in the COM port it is not available. COM8 is not at all connected. Okay. Now once again I'm going to connect it back the hardware. So once I connect it, so it is updating now. So now you can see the ports. You can see that Silicon Labs EAR bridge is using communication port 8. Okay. So this is for finding which hardware is connected to which communication port. So once you know this one, you can go here, tools, port, COM8. Okay. So usually COM8 is what connected in my system. Depends upon system what you are going to use and which USB port you are going to use. Okay. So once it is connected, you can go for uploading the program. Okay. So go for the second option. So now you can see it is compiling the sketch, and you can see the last uploaded program. It is blinking very fast. But now what program I am going to upload? It is going to blink very slow. Okay. 1 second, one time alone. So it is compiling the sketch. Once it is compiled, it is going to upload it in mruby. Based upon mruby, it is compiled. So only I have given all as PPT presentation. If I run it in real time, it will take a lot of time. Within this time, you cannot. Okay. Now it is connected. It is uploading. So you can see when it is uploading, this is blinking. So it is showing that something is uploaded into my hardware microcontroller. So you can see 46, 53, 61%. So it has to complete 100%. So 100% is completed. Now we can see blinking very fast. Blinking has been changed to blinking in 1 second. Okay, so this is how you can upload the program from mruby. Okay. So with this, I am going to end my session. If you have any doubts, you can ready to ask. Any doubts, you can ask me that. So is the time. So the complete presentation, I will give it to the FDB coordinator. So from the you can get it. Okay, this PowerPoint will be available with them, so you can get it and you can use it. If you have any doubts, you can ask me. Okay, I think it is a software installation and the PPT is available. You can anytime have it. Okay. Okay. Thank you. Thank you, the coordinators of Christ College for this opportunity and very special Dr. Tyaranjan sir for giving this opportunity. Thank you. Thank you all.
Thank you, sir. Thank you for your information regarding Arduino ESP. So, participant, anyone is having any doubt, so you can kindly raise your doubts. Sir gave us a deep insight regarding the Arduino programming, ESP32 programming, and installing all those things and how to execute those things. If any of you is having any doubts, you can kindly raise it. And also, participant, the feedback link is shared in the message box. You can fill it for both the session. No questions? Thank you, sir. Thank you for your valuable
Thank you, sir.
information. The session was
Thank
really
you, sir.
informative.
Okay, sir. Thank you.
Thank you. So kindly fill up the feedback link which is posted in the message